Welcome to this video where we'll look at how to solve problems using the suvat equations. Firstly, make sure you're familiar with what each of the letters represents. And these are the 5 equations, though as this is aimed at A-level physics, where only these 4 are generally considered, we're going to concentrate on these 4. We're now going to work through these 6 steps, one at a time, with an example problem. Our example problem is that a squirrel falls from rest from a branch that's 5 meters above the ground. We're told we can ignore air resistance and calculate the time taken for the squirrel to reach the ground. Step 1 is to draw a diagram and include an arrow to show the direction which is going to be taken as positive. We're told that the squirrel at the start is at rest, so we can say it's at 0 meters per second at the start. And then by the end, it will have fallen 5 meters down, so we can label up 5 meters down. We aren't told its speed at the end, and I'm going to define downwards as positive. Step 2, we're going to write down all the information that we know, put a question mark for the thing we're trying to find, and a cross for the thing that we don't know and we're not asked to calculate. We can see that the displacement is going to be 5 meters between the beginning and the end. We're told that it was starting at rest, which means it's going to have an initial velocity of 0 meters per second. We aren't told the final velocity, and we're not interested in finding the final velocity, so we can put a cross next to it. The squirrel is in freefall, so we can write that its acceleration is 9.81 meters per second squared. And note that because we defined downwards as positive, the displacement and this acceleration are both positive, and the time is what we're asked to calculate, so we're going to put a question mark by the time. Now we need to select the equation which doesn't contain the quantity we don't know and we don't want to find out. We aren't told the final velocity v, and we're not trying to work it out, so we need the equation which doesn't contain v, which is s equals ut plus a half at squared. Step 4 is to substitute the values into your chosen equation. So instead of s, I'm going to write 5.0. Then as u is 0, I'm going to write 0t plus, and since my acceleration is 9.81, I'm going to write plus a half times 9.81 times t squared. I can then simplify this down to 5.0 equals 0, which I don't need to rewrite, times a half times 9.81, which is going to be 4.905 times by t squared. Step 5, I need to change the subject to the equation to, in this case, find t. Because I've got 4.905 times almost the thing that I want, the first thing that I'm going to do is divide both sides by that, which will give me 5.0 divided by 4.905 equals t squared. I can then square root both sides, and I'm just going to write it the other way round, which will then give me t equals the square root of 5.0 divided by 4.905. And I can then put that into the calculator, and that will give me 1.00963. The final step is to round my answer to a suitable number of significant figures and give a correct unit with it. Since my worst bit of data was given to 2 significant figures, I'm going to round my answer to 2 significant figures, which will make it 1.0, and it's time, so the unit is going to be seconds. So my final answer, 1.0 seconds. I'll finish with a few tips that will help you with other suvat questions. Always remember, if it starts from rest or goes to rest, then that means 0 meters per second. If it's reaching a maximum height, that means the final velocity will be 0. Make sure in your writing that you can tell the difference between a u and a v. Always write your u with a tail and your v without, and then even if it gets a bit messy, you can tell which was meant to be a u and which was meant to be a v. If it tells you that it's in freefall, then the acceleration is equal to 9.81 meters per second squared, or whatever your exam board requires. Often in maths, they want you to take it to be 9.8. Watch out with this to make sure that you're defining which way is positive and which way is negative, as if you have things in more than one direction, you have to be careful with that. For example, with a ball going up, but the acceleration due to gravity acting down, then the velocity and acceleration will be in the opposite direction. Remember, you can only apply these equations when the acceleration is constant, And if you have a situation where the acceleration is 0, then you can make things easier for yourself by just using that displacement equals speed times time, which is much simpler than using the suvat equations. I hope you found this video useful.